Now for the real thing, I guess. There you go. That's okay. Should I start? Yeah, all good? Yeah, all right. Folks, thank you so much for joining this session. My name is Mauricio Salatino. I work for like an observability company called Dash0. And I do go to a lot of Kubernetes events, right? Like this one, right? Like KCDs, like KubeCons, and I've been doing that for quite a while. And I've seen a lot of different conversations like we saw today, like in the keynotes, right? It's all about infrastructure. It's all about like running GPUs. It's all about running LLMs. But I do see different versions of the same story if you go to different events. Like if you go to developer events, they are all talking about building agents. So this presentation is a little bit different from what you saw today in the keynotes. This is all about trying to come up with like a unified story between developers and all the infra people that it's running infrastructure for Kubernetes, for running agents, for running LLMs, right? I titled this presentation reacting to AI, but of course that we are talking a little bit more about Gen AI specifically, right? What are these agents doing, how they are working, why are we building agents at the end of the day? So the more I looked into these solutions, what companies are building all over the world are distributed multi-agent systems. And these systems, as we saw again in this morning keynotes, they will talk to a lot of the LLMs and they will just put a lot of like pressure into our infrastructure, into our systems, and into people managing these applications as well. So talking like, again, when you go to different conferences, if you go to developers, they will be talking about agentic frameworks, MCP, A2A, and skills, right? Like that's a very different conversation that when you go to infrastructure conferences like this one, where you see about like GPU scheduling, LLM routing, and semantic caching, the presentation that we just saw, right? So these topics, they need to converge at some point, right? Like whatever we are building with these agentic frameworks, they will need to run on top of our infrastructure, and these topics are extremely related. But we need to dig deeper a little bit more about like what our platforms need to support in order to be able to provide developers with the things that they need in order to build these applications, right? Most of these agentic frameworks that we see today, they have been built with different concepts than the ones that we have in the infrastructure side. So we need to start combining these stories together. From a platform level, right, we need to deal with new protocols, right? Like when we talk about MCP, you know, I am assuming that everybody knows what MCP is, right? What about A2A? How many people have used A2A before? Okay, we have a couple of hands, right? And again, like developers are looking into these protocols to communicate agents, right? And these protocols, they come with new challenges. So for example, I will not talk about like MCP, but like on the MCP side, you will need to run your MCP servers and you will need to manage them at scale. So that's like a new challenge that we need to figure it out. When you look into A2A, A2A is a protocol that was introduced by Google, right? And it's designed to communicate agents to talk to each other, right? And compared with other protocols, the big difference here is that they do a lot of streaming, right? So you can exchange text between agents, but also you can exchange videos and you can exchange audios between agents. And that's a thing that, for example, as a developer, I haven't dealt with. And when you need to like scale up these protocols, it's kind of like a completely new challenge that you will need to figure out. The same with skills, right? You know, like if you're using Cloud Code or any of the coding agents, you need to build the skills to make your agent understand a little bit more about the specifics of the things that you are building. But I don't see many conversations about how do we version these skills, how do we package them, and how do we distribute them, right? If you're running an organization with tons of development teams, how do you share skills across these teams? And how do you make sure that they are versioned in a way that if somebody changes these skills, the other team that it's like maybe in a different office can get the same version and use the same thing for the agents, right? Important in an important distinction here is that I'm talking a little bit about like the agents, not the coding agents that every developer will run in their laptops, but the agents that are going to perform like business operations. And those are the tricky ones. And for that, like over the last 6 months, I've seen some sort of like unification of how the industry think about these systems. And that's kind of like where the term agentic engineering is popping up more and more. How do we build these agentic systems that do more without us like being on top of these agents, like observing them and just verifying every step that they take? That's why like the 5 levels of agentic engineering, you will find these like with different terms, with different names, but basically what the industry is trying to define is how do we move forward to the next level of automation. And when you talk about agentic engineering, you are talking about autonomous systems, right? Think about like the autonomous, like the self-driving cars, right? The car industry has taken quite a long way to build these cars, and they are still not ready for production, right? Like they are being deployed in some cities and they are kind of working, but they are not massively adopted, right? So we need to go through a similar transformation in the software side of things for all the other industries. So what I've seen so far out there, and this is after talking to a lot of different companies trying to build these systems, is that they have classified different levels and you need to move one level at a time. The first level is generative AI assisted, right? We are using LLMs to get alternative, to get suggestions, but at the end of the day, the user decides which suggestion to pick and to move forward, right? You are in full control. If you move forward, it's kind of like what we are seeing today with coding agents, right? We have a coding agent that can create resources, create source files or change configurations without like too many instructions. You just write a prompt and you get just like the modified resource. But the end user still needs to review every change that the agent makes. And this is where where I see the industry hurting today, right? We are using coding agents all over the place, tons of changes are being created, but we have hard time reviewing all these changes and making sure that these changes will work in production environments. And remember, this is like only for coding agents. Imagine like if you put like a different kind of agent for doing a business operation. The next step that people is trying to work with, and this is kind of like where I see the industry creating a lot of new tools to figure this out, is the spec-centric space, where we have a formal way to describe what we want to achieve out from the agent and how do we validate that that's actually happening. So think about like a meta level where you can just express like in a prompt-like experience what you want the agent to do, and you have a way, in a formalized way, to check that the agent did what it was expected to happen, right? In this case, the idea is that we don't need to review every change that the agent produced. Think about code, right? Like you don't need to check every line, but you check the behavior of the code when it's running in production, let's say. And that takes you to the next level, which is kind of like what we are actually trying to build, but I think that we are still pretty far from there, which is the selective autonomy. When you start thinking about autonomy for agents, what you see is that you actually need to build like some infrastructure components and a lot of software to actually measure how much do you trust each of these agents. And in order to build trust and confidence over agents, you actually need to record how these agents are operating. So you need to capture a lot of data, right? And I do work for like an observability company, so we are used to capture a lot of data. But we now need to use that data in a different way compared to our production systems that we saw before, right? If you start building trust networks and trust like confidence in your agents, you can actually start thinking about, okay, we can let the agents go and do stuff, right? Like we saw the term this morning about like AI factories or dark factories that are basically doing stuff, and we just let the agents go and do things. But I think that we are still pretty far away from that because there is a lot of tooling that we need to build in order to actually reach there. As I mentioned before, like we have the tools, we have open source, we have Kubernetes, we have the cloud native ecosystem, providing a lot of like common ground for our platforms to build all these things that we are missing, but we can start like using the same vocabulary that we already have, right? Like in the previous session, we saw LM Cache providing CRDs for us to deal with KB caches, right? We will basically build more tooling on that space. We will keep extending Kubernetes to be able to support these new agentic workloads. But I get this question quite a lot. And again, like if you go to talk to the finance industry, if you talk to the healthcare industry, they start kind of like, depending on who do you talk to, they ask different questions. It's like, where do we start? What do we do next? Do we deal with infrastructure? Do we deal with like developer tooling? Do we deal with how do we productionize these agents and how do we check these agents to move forward? I would say that actually we need to figure out first what are the problems that we are trying to solve, right? So what I have here is like a small demonstration about like a home banking application, right? Imagine that I'm trying to perform like a transaction here, and I actually, you know, succeed in submitting the transaction, in this case to my mom, so I send in some money. You can see that the date here is the 10th of June, but if I go and see into my transaction list, I don't see that transaction there in like the right day, right? So I see it on the yesterday section, right? And finding kind of like this kind of misbehavior from the application point of view, it's really hard. Our platform will not see any error. We will not see any alert raising, right? But what we will see probably is like a customer creating a customer support issue saying, hey, I was supposed to see the transaction that I just did in today's category, but it's not there, right? There is something wrong. So the customer support team will just go and investigate transactions. It will figure out the databases and just check the data and then say, well, the data looks kind of like right, but the end user is reporting that they are not seeing the data in the right place, right? So imagine that business scenario. You have an issue. You also have like a customer support issue. What I see a lot of companies in that level 2, which is like they are using a lot of coding agents, but they haven't improved kind of like the entire software delivery cycle with agents. What they are trying to do is they are trying to basically bring agents closer to optimizing CI, optimizing CD, and then just using the tools that we already know to build that. So for example, in this specific scenario, what I will see is like an issue got created. So basically what we can do in our CI pipelines is just put an agent to identify what the problem is and then just try to generate some code to fix it, right? So what you see here is like, I don't know if you can see it from there from the back, but the agent identified the problem in the source code, created an issue, and then there is another agent that will just check that this code is like conforming with my company policies, right? So it's going to augment that pull request. And after that, our CI pipeline will run, and we can use techniques that we already know in the cloud native space, like creating preview environments, for example, right? And in this case, the pipeline is creating a preview environment that will run the application, right? It will run a copy of the application, and there will be another agent basically validating that the behavior of this change is correct, right? Like in this case, it's going to check that the transaction is appearing in the right section, right? Like in today's section. Once this validation is performed by the agent on a running application, now we can basically assert that the change actually did what it was supposed to do. Now, as a reviewer of this pull request, you can see here down the bottom, what I'm showing here is like 3 boxes, basically, right? I'm not interested anymore on the code changes that the agent did, but I'm interested more on knowing that an agent-generated code, that the pull request is actually up to standards, and that I also did like an intent validation on the changes, right? Like the changes actually implemented the things that I wanted to implement. It fixed the customer issue based on the customer support request description, and that's running in an environment that I can validate. Right? Now, companies doing this, like adding agents to their CIs or to the CD pipelines, right? They start facing some issues, right? Like the moment that you want to automate adding non-determinism into your pipelines, things will go wrong at first, right? And this is what I'm showing here, right? So if you start measuring your AI adoption, there are like groups basically doing research on this and finding that you need to pay some sort of like AI adoption tax, right? And this basically means that in this case, the deployment frequency will go down for a while until you figure out how to do automation with these kind of systems and bringing different agents that will be running in different places to work together to actually help you to speed up your software delivery practices. The same here with change failure rate, right? And I strongly recommend you, if you haven't checked it out, this is like the DORA report on return of investment of AI-assisted software development. This was like published in 2026, so this year, like early this year, and it basically talks a lot about like that, the challenges that companies face when they try to build a lot of like automation with AI agents. So 100% recommend. And what I'm showing here is the DORA metrics, right? Like deployment frequency, change failure rate, change lead time, and failed deployment recovery, which are like basic metrics that you can start measuring tomorrow to figure out if AI is helping you in your software delivery pipelines or it's not. And again, from like an observability point of view, right, I'm very used to see traffic, all the information that's coming from our production environments, right? Like you're running your production workloads. We are like using OpenTelemetry to see what's going on, to figure out what goes wrong. But in order to calculate these metrics, you need more information. You need information about your CI/CD pipelines, you need information about your PRs, your issues, and you need also to correlate that with your customer report issues as well that they are created, so you can verify that, okay, when the customer reported this, until the time that we fix this issue, we can actually measure the entire cycle. And that's extremely important because the more issues you face by adopting AI, the more that it becomes apparent that you need to deal with non-determinism, as I mentioned before, adding agents and all the strange behavior that these agents might be causing at the platform level, right? So in this case, I have a demo, just a simple example of an agent or like a pipeline that basically tests different models in order to figure out which one is best, right? So I have 3 different columns here trying to solve the same problem, right? And I see a lot of companies trying to do this. So in this case, you have 2 models that go fast and one that takes a little bit longer, right? Of course, if you're using different models, they will perform differently and they will also cost differently. And I think that this is all good, right? So basically we are just evaluating 3 models, and then what we can do is use another model to say, okay, we will rank these solutions based on some scoring that we have here. So we have different dimensions to say, how correct is this change? How robust is this change? And then based on that, we can say, okay, this is the best change of all of them, and then we will just apply that and test that into a preview environment, right? Like doing the same thing that we did before. But what it's becoming more and more apparent is that we actually need to record the decisions that we make along the process, right? So imagine that you made a decision here saying that this model is the best for this task, but also we compare against these other 2 models, and also we perform like an intent validation, right? Like we verify that the change actually did what it was supposed to do, and we also measure how much did it cost, right? If we start capturing all this information, we can actually start learning how well our agents are performing, so we can start making them better the next time that they execute a similar task. And as I mentioned before, agents are not going to run in our Kubernetes cluster alone, right? Like we can just run some agents in our Kubernetes clusters, that's for sure. But nowadays, we have a lot of agents running in our developer laptops, right? We have coding agents generating code that we have like not much visibility on what these agents are doing. We have agents running in our CI pipelines, right? And we have agents maybe in our preview environments also checking what the application is working, and agents connecting to our production data to help us to troubleshoot what's going wrong when they go wrong. So if you ask me about like what I'm seeing out there, is that I see the urgent need of figuring out like at a company-wide level, how many agents are running, where are they running, and what are they doing, right? For example, how much do they cost? Like the combination of all these agents running together, that they are probably running in different runtimes, right? Some of them, they will run in our clusters, some of them, they will run in our CI pipelines, and we need to measure cost and also try to understand what these things are doing. So if you ask me as a platform engineer, how do I build a dashboard like this, I will probably use something like a telemetry collector. I will collect data about all these agents and try to create a dashboard like this that shows me in an aggregated way, in a quick way, where are these things running and how efficient they are. Luckily for us, we have the Open Telemetry community that they created the Open Telemetry Gen AI semantic conventions that allows us to plug into all the agents, no matter where they are running, to collect the same data about these agents, right? Like which models are they using, how much do they cost, the tools that they are calling, which is extremely important to understand where is like the impact in our platform is, right? Like which APIs are these agents calling? Which are the APIs that are being called like 1,000,000 times compared to the ones that are calling 10 times, right? So if we want to optimize, first of all, we need to see what these agents are doing. And if we start seeing what these agents are doing, the next step is actually to close the loop, is to use that information that we are collecting, it will be quite a lot. We need to compress it in some sort of like a signal store. A signal store is like a term that is being used to basically correlate all this information that we're getting, right? I'm not interested in getting all the steps that an agent performed, but I'm interested in trying to aggregate that information so I can consume it to make my agents better. So what I'm showing here is that we get information. Imagine like you get like all the metrics, all the traces, all the logs from all the agents that are running. The next step is you combine all that information to say, well, this agent is performing tasks related to this topic, right? So you classify the agent. And the next step is to build the trust network that I mentioned before. Remember, like moving from level 3 to level 4, we need to start building confidence into our agents. And in order to build confidence, the only way to do that is just to measure and look into what these agents are doing and to figure out if they are doing it better the next time that they run or not. If we have kind of like a trust network and curated context networks, and I think that caching becomes super relevant there, we can start feeding that back to our agents, right? So if we have another agent fixing kind of like a time issue in our application, we already know how we fixed the previous issue before, so we can use that database of knowledge to improve the context of our agents. And then we need to build this pipeline back. So how do we push this curated context to the agents that are running in different platforms, right? So I see a lot of platform engineers trying to figure out how to build these last 2 pieces of the puzzle. And there are tons of tools that are going to pop up in that space. So I'm really, really curious to see what you folks are up to in that space, and how are you basically trying to improve the way that you use, for example, your coding agents with more context based on the problems that you're trying to solve. As I mentioned before, 4 key takeaways from the presentation is, again, I think that this is something super important for the Kubernetes community. Agents are running everywhere. They are not running in your clusters alone, right? Like they will run in different places. More importantly, nowadays we see a lot of like developer-led, coding agents. So we just need to figure out how to observe them and how to collect data from them. LLMs do not learn. This is super important. Again, like we can train LLMs and we can make them better, but the moment that you stop training them, they will just perform the same task all over again in the same way, not improving performance at all. So we just actually need to provide that as part of the platform. Non-determinism, as I mentioned as well, is like it's part of running against LLMs, and all these agents that are using LLMs behind the covers, right? They will be non-deterministic. So if something goes wrong, your platform will need to deal with that. And finally, as I showed like in the dashboard, like measuring using DORA metrics to figure out if you're improving your delivery pipelines is extremely helpful to understand kind of like if you're doing better or not compared to yesterday. I do see a lot of people adopting AI like crazy, but actually not measuring anything. So you're just running blind and trying to hope that you are actually making your life better, but you actually don't know because you're not measuring. So we have the tools in the CNCF ecosystem. There are tons of interesting tools in that space, like caching, using GPUs, running GPUs, GPU slicing, scheduling, and all that stuff. Now we need to figure out how our developers are building agents and which frameworks are they using so we can actually help them to build systems that can be more autonomous. And I think that that's the big change, at least in the Kubernetes community. Before we were used to just run our applications and just look at how these applications perform. But now we need to close the loop and bring all that information that we are picking up back to the agents that are running, and they can be running in different places. So I hope that you're having a wonderful day, and I hope that you enjoy the conference. I will be here the rest of the day if you want to chat or if you have other questions, so feel free to reach out, and there is a blog post there as well where I try to summarize the context of this presentation. So thank you so much for listening. Thank you, folks.
Mình có khoảng 4 phút thôi để Q&A, thì mọi người có câu hỏi gì? Okay.
First, thank you for the presentation. I have a question about the last part of the puzzle, the trust network and created context.
Yep.
So right now, I think for what the industry agree on is like skills and plugins for your agents. Do you have any other recommendation on what can be improved upon skills or like plugin for your agent?
Yeah, so I think that like that's the problem that I see with skills in most organizations is like how do you share skills and how do you version them? And how do you track dependencies between skills, and how do you make sure that your developers are actually using the right ones? My recommendation there would be to basically start testing performance on skills, right? And then just capturing that data so you actually know if you're improving or going in the wrong direction. Regarding skills, there is like there are like these tools that basically will allow you to scan your skills for performance. So scoring skills might be kind of like the first step, but then keeping track of that score and figure it out if like you find the right way to improve like performance on skills is super important. But that's not what I'm mentioning here. This is kind of like actually the next step, where you can actually keep track of which problems do you solve with this agent, which skills were you using, and then just recording that output to figure out if you need to improve your skills or not, right? Because again, like if you're not measuring what you're doing, it's very hard to know how to tweak it to work better. So hopefully that answers. It's a little bit fussy because that's kind of like a lot of development in that space right now. So yeah.
Thank you. Maybe we can talk a bit more later.
Yeah, we need to talk about that. Yeah, 100%. Thank you.
Còn 2 phút, nếu mà có ai có câu hỏi ngắn thì có thể một tí thôi.
I have a question. Do you know some success story which apply this model, this platform, which deliver the good value?
Yes, so I think that that's a very good question, and I think that's why I push really hard on the measuring side of things, right? I see a lot of companies trying to implement these systems, but because they are not measuring, it's very hard to measure success, right? So for me, like what I'm seeing in the industry is that we have switched from collecting information to start using that information. I do not see a lot of success stories in the sense of like we have data to prove that this will work. So we are, as an industry, we are trying to figure out how do we do that, right? So but in the other hand, I do see some use cases that makes a lot of sense to build, like in an agentic way, like for example, exploring a lot of documents and classifying information. But besides that, like again, if we don't measure, it's really hard to say we are like successful in doing this. So very good question, and I hope that next time that I present about this, I have some use cases and case studies just showing kind of like this approach. One more thing. On my company side, right, like so we are building these tools for companies to basically use that data, right? And what we are seeing in our customers is that they are getting value out of figuring out which skills are being used and which skills are not being used, for example. And then from there, they will just need to improve their skills so we can actually measure to see if they are successful or not. But besides that, yeah, it's a forever changing industry. So thank you for the question.
Thank you. So I think it's so good. Thank you.
Thank you.